G'day, everybody. Thanks for watching. Yes, it's me. Look, hello. This is a show focusing on plant science, soil science, and microbiology. The information provided is fact-checked, and any of the websites or papers discussed will be put in the description below. And today's topic is all organized. So it's all organic versus synthetic in agriculture. What's the difference? Why should you go this blooming organic route like everyone's talking about, huh? Well, we're still going to go right into it. Heaps of slides to go through. And some guests, which prompted me to put my head on. You can see me. Hello. So there is. Got Yield Source. Hello, Yield Source. Nice to see you, mate.
Cheers, 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 everyone.
Hello, Loki. Can't hear you, actually, Yield Source. I might have to unmute you. Uh-oh.
Can you hear me?
I can't hear you. Does that mean I can add the noise to this? Uh-oh. Testing my mic. My mic works. Good.
Testing. Can you hear me?
Testing. Can you hear me?
Oh, no.
I can hear Loki. Loki, can you hear me?
It was working perfectly before.
Everything's good, Aussie. Everything's good,
I can hear both you
CC.
guys.
We're good.
Can you write in the private chat what I might have to do? I press on the little edit mic settings, and then it just goes. It doesn't even show like an option to. It says it should work. Oh, does it work now? Oh, is it my computer? Yes, it is. I'm sorry. I had mine on mute because it comes up with my background. So yours works fine, doesn't it? Can you guys speak? I can't hear you though. oh, I can hear you now.
You hear us?
Can you hear me now as well?
Good. Okay, guys. So today is nice to hear everybody. Seeing chat. There's 420 Fred. Hello, 420 Fred. Nice to hear you all. Okay, good stuff. Thanks for your feedback. So at stage is that, and the slides. So do you guys want to say anything before we start going into the debate, organic versus synthetic stuff?
Oh, not at all. We don't. I don't have a major background. It's just I am on YouTube as well, Yield Source, and would like to bring more light to certain subjects because a lot of people are in the dark. So we want to shed light on a lot of things, and no one can do it better than RCCC. I love this guy. So we're here for all the support for sure.
Thanks, mate. Nice words. And Loki, you're just going to tag along, mate?
Yeah, I've been growing for about almost 2 years now, and I just love my organic because of simplicity.
Yeah, good stuff. Well, this is going to go right into it, and we can see why. Why should we blooming do it?
Why?
Is it really worth doing? Is it worth all the extra effort? Let's see why. Okay. So I'll share my screen. So we're going to go through here. This is a university course that I did a few years back on organic. What's the name of it? I'm just sharing. Oh, it's the wrong course. These are the courses I've done. Organic farming for sustainable agricultural production. This is the one that we're going to go through a lot today. So first I'll pull some slides up here. So quality of organic food. So here it is. This is the course, where it's from, and that was the Professor Dillip. It's from India. I'm not going to go heavily into it. Why people choose organics. You can stop this and read it yourself, because I'm only going to skim, like just stop on the basic stuff that's kind of important for like nutritional quality, as an example. Primary essential nutrients are a lot higher. Secondary metabolites, phytonutrients, are a lot higher in organics, and this has been proven. Like the secondary metabolites or phytonutrients in plants, there are some 5,000 to 10,000 secondary compounds in plants, which are considered as health promoting and protective and necessary for health. They're like phenolics, terpenes, alkaloids, sulfur containing compounds. Stacks. There's some evidence. I could really go a lot into it, but there's a lot of slides to go through. So if you just want to look back on some evidence, there's the papers and things that you might want to go through. I'll just go through stuff like this, these charts and facts. So this is a comparison of the content of nutrients of other nutritional relevant substances in organically and conventionally grown crops. So there's the nutrient on the left and then the comment on the right. So you can see, for instance, nitrogen, organic versus conventional. No.
One second, CC. We're not seeing your screen. You got to share it. Yeah, you got to share it the same way.
Okay. Thanks for bringing that up. Entire screen, yep.
The same way you shared it backstage. You got to. There you go.
That's better. Oh, there you go. That's better.
There it is.
All right. And can you see this?
Yep, there you go. That's it.
All right. Sorry about that, people. This is where it started. So you can see that's the course. Professor. There's the first bit. So I didn't want to read just about chemical fertilizers. That's another bit too. So we're talking about nutritional value, but what about the chemical bits too? So that's why you go organic, because organic doesn't have to all the chemicals and bad bits of glyphosate that do all sorts of affect our micro pathways and all sorts. So that's another part of it too. But this is really getting into the nutritional value. There's those papers that you might want to go through if you want.
All right.
There's the so for instance, nitrogen, you heard what I said before. Well, vitamin C is a good example because there's no difference in organics versus conventional growing. No different. But there is with phosphorus, nitrogen, and acidity, and then that's just in the nutrients. But then this secondary metabolite profile is humongous. You saw of the 5,000 to 10,000 differences. Well, this is what this goes into a fair bit. And I'll touch into that later with the different ORAC values and the catechin ratings and stuff that there are. Pesticides. Huge. So conventional, okay, the fruit and veg. You can see fruit's pretty high, veg. Integrated pest management, and then there's organics. So the integrated pest management is where they might have used a bit of bio and stuff like that, where it's sort of in the middle. Conventional is just full on pesticides, kill everything, poison everything, glyphosate, herbicides, everything. So look at the difference in this, just in the pesticide residue. So if you were to buy off the fruit and veg shop, or if you were to get your good looking greens, you might have a higher chance in reducing the residue. That chart says that based on 2002. You guys at the background are welcome to chime in and ask any questions. I used to stop this maybe every 10 slides just to see if there's anything in chat, but you guys are welcome to just interrupt whenever.
Okay.
What's this
I
saying?
kind of worry about, even though stuff says organic, like the stuff that I use comes from the seafood industry. It's waste product, basically, the shells, the entrails and stuff like that. But it comes from the ocean, and we don't have the purest oceans on this side of the pond. So you got to worry about sometimes about your heavy metals getting into your organic substances. That's the only problem. Just because it says organic doesn't mean it's pollutant free.
Yes, that's right. Things accumulate stuff. That's right. And all the heavy metals, toxins, poisons, chemicals, they all go accumulated into the tissues of the plants and all the different things that we eat and consume. And that's all the plant material that might be even extracted out. It's still in that material that gets extracted out. That's the poisons and heavy metals and residues. That's not good. Is another chart, pie chart of the organic fresh produce versus conventional fresh produce, residues, 3/4, and this is nearly 3/4 of residue, with only 5% you could say would be in it. But we already sort of know that. Nutritional bioactive, food digestibility and nutrient bioavailability are the heart of nutrition. Digestibility is the measure of how much nutrition or food provides a given volume. It indicates how much food is absorbed by the gut in the bloodstream. So yeah, can it get in and do its job as well? So some of that synthetic stuff, you know, it doesn't go through the pathways that it should. The pathways that you want to activate all these healthy things to get them all clicking in the right ways, you might be acting some pathways that it doesn't recognize. So therefore it's going to maybe act as a poison or something like that and create a cancer causing thing. So it's another point that's good to be raised. Oh, the shelf life, of course, yeah, it'll stay longer. Sensory evaluation, that's how they test the products. They get people in the rooms and they do different tests and things like that. They've also got now e-noses, electronic noses, and electronic tongues to do this that job. Comparison of weight gain of organically versus conventionally grown food in rats and mice. So that's an animal test that's done on it. And you can see what it says, no difference, low mortality. Yeah, okay, you can go through them if you want. Some things to be concerned about. Cadmium, this is what Loki was saying before about the heavy metals and things getting accumulated. This is exactly what he was saying about the pesticides and things that get accumulated in the tissue. It's all about there. It's another fact. That's it for that slide, for that lecture. There's a few more here to go, like the antioxidant capacity. What is it? I'll stop and see if there's anything in chat. There's nothing.
So the question is, how does the heavy metals accumulate in the tissues, whether it's organic or inorganic? So if it's inorganic, wouldn't they screen for heavy metals? Wouldn't they screen for these toxins when it's inorganic? And when it's organic, there's nothing there to prevent these heavy metals. There's nothing there. So, like Loki was saying, we get the substance from a courier or a place that sells a product that says it's organic because they got it from an organic source, but they may not have screened for these inorganic materials that are getting into the tissues and the fibers. So in that case, what would be a better solution? Would it be inorganic, which is synthetic nutrients, or organic?
It'd be know your source or trust your source, because like you said, it still says organic these days, but they're only going to test for a few things that they test for, and there's organic certification stipulates for so many, like if my farm was organically certified, you get so many inspections each year and you got to fill out things and process stuff like that. But people can lie. It's a money thing. And if they're going to fail a crop, they might just do one thing to pass it through and lie. So it's the rating to go by, but to trust by the gospel, it's really grow your own. It's really, you can only trust yourself and trust the people you know.
So at the end of the day, synthetic nutrients would be the go-to in that situation, because it wouldn't be any inorganic materials in synthetic nutrients because they were made in a lab like a synthetic diamond.
Not necessarily, because I use kelp, and my kelp comes from the other side of the world where the water is much cleaner than it is over on our shores. So I think they get the kelp from like Norway or something like that. And it's,
but
you know, I use kelp in my garden because it's a natural growth stimulator, a natural growth hormone.
I'm sorry. The question is, do they test for inorganics when they sell you the kelp? That's the real question, because you have no clue what's in their waters because you don't live there, you're not there, and you don't know what they collect, and you don't know how they collect it, because in their method in which they collected could introduce microplastics and other things into how they collect it. You know what I mean? So
Right.
there's a lot of things that are involved that we don't know, but at the end of the day, synthetic nutrients may win this debate on pathogens in your organic materials that they may or may not test for.
But when it's processed, the crab shells and lobster shells, there's some heat involved, and the heat can kill some pathogens.
Yes.
I don't know what it does to the heavy metals, but it'll kill pathogens when they're drying it out, burn it. Because you got to get, I can tell it's crab because crab
And
turns
that heat
goes from
may
blue
also,
to orange when it's cooked.
That heat may also kill minerals and other nutrients that would be even more soluble if it was raw and organic. Because just like your food, when you cook your food, you process your food when you cook it. And in that process, you destroy other things that would be absorbed in the body.
Yeah, like if you overcook your vegetables, you pretty much throw all your vitamins out with the water you throw down the drain. So I try to steam my vegetables.
And with the input of the organic versus synthetic feeding of the plants, for instance, if it's in an area that's going to accumulate the cadmium, it won't make any difference on what its feed source is because it's going to accumulate it regardless. Does that help to your question, yield source?
Yeah, it does. It's gonna pull it regardless, right?
Regardless, yeah. There's not much you can do because that's what they're hyperaccumulators. The plants, they just love to suck things up. They got vacuoles, and in their vacuoles they store the pH is 5.0, and it's a lot lower, so they can store all these problem things and the chemicals and that goes into the vacuoles in the plants, and that's how they accumulate it. So when you do phytoremediation, so if there's a big paddock that's been destroyed, and you do phytoremediation, which is putting plants in to suck up all the badness that's been polluted in the area, they'll go and just get all the green leaf material and just burn that or put that through filters and all sorts of processes because that's accumulated all the stuff out of the ground. Over.
So sort of like a sacrificial crop. You put it just like you want to put something back into the soil. You can take stuff out of the soil by just growing a certain crop there to pull that out.
Yep, exactly.
That's awesome. It's nice.
Yeah, I like my dry organic amendments because I think for the new person that's new to gardening, it's easier. You just put all your stuff into the soil, plant your vegetable seeds, and go from there. And I use like an old Native American trick too, because I'm a terrible fisherman, so I always have leftover bait. I put fish in the ground, and then I put my seed on top of that and bury it. So you got natural fertilizer that way.
Yep, there's the go. And there's a bit of a buffer too, because all these extra things that are in there, you're going to get different microbes and fungi that are going to be added, which could be which are going to work symbiotically, hopefully, and all work each other out. And then you get all the different nutrients that are going to slowly break down from all these different organic inputs that you're going to get. And then the buffering effect. So for anything that's going to go wrong, there's going to be nutrients that are going to be bound up. So if things are nutrients getting used too much, nitrogen, all right, we'll just break this down a bit more. Nitrogen A's can come in and break nitrogen molecules down and make them available, as an example. So yes, there's a buffering system with the organics. It's pretty cool.
Is there some way you can bind the toxins and flush them out with some type of organic or inorganic agent? Because we're talking about silica, and if you put silica in your water, if you put something else in your water and then you add silica, you get a snow globe effect. Because I think that's the silica or the calcium maybe falling out of solution when you mix it in the wrong order.
To flush the nutrients out, you let the plant, because it's going to accumulate anything. They're going to be sitting in the vacuoles anyway. Like when you'll finish a crop off, if you're going to produce seed, you might let it die. So after it's died and all the material's brown, the brown, so all the nitrogen's gone out of it at least. So that's one of the elements that's gone. But flushing the whole plant, I don't think you can actually cleanse it in the sense of putting a bleach system through it, like on a kitchen system. It's like if you're going to bleach your kitchen top, you can't there's nothing you can do to the plant without that's going to kill it, because they're going to still hold them in the cells, in the vacuoles, and they're edioblasts. They got different plastids in the cells, and the edioblasts, they hold fat and oils. That's the tissue, the cells that hold those types of things. So you can't. I don't think it's that easy.
Well,
From my understanding.
maybe getting it out of your soil. You know,
Soil?
just try to because I'm a soil grower too. I'm loyal to the soil. I just love growing my plants in soil. You know, my raspberries, I keep them in the back of the yard. They grow in soil. Just leave them alone, and they just do their thing.
Yes, soils are heaps easier to work with because you know it's going in, and whatever's in there, you can virtually pull it out, do a few weed crops, and you know everything's pulled out of that, mow it, let it go back in, and as long as you can see that all the colours are all right in the leaves, that's a good indication that everything's grown well. That it's but you could get resistant strains too. So if you get plants that are growing in mining areas, they'll keep growing, producing seeds, and all of a sudden you get ones that show no effects of the mines, like they might be iron resistant. So that's, I was sort of might sway a bit wrong from saying that. Sorry.
Well, I got a question.
Sustainable is like, I see my neighbors throwing away their lawn clippings and their leaves at the end of the year. They having them hauled off somewhere. I'm like, I'll take those. I stick them in my garden, let them decompose over the winter time. So, and then I break them into the soil. You start doing that every year. You're replacing all the crappy soil and putting in good soil in there. Maybe you're building your own basically outside on a bigger level.
The compost is another thing, and to summarize that, it's a carbon to nitrogen ratio with your compost to have it perfectly, so it breaks down and keeps those elements at the end. Doesn't go too fast with too much nitrogen, doesn't go too slow with too much carbon. And perfect, you want a CN ratio of 1:24. So 24:1, sorry, and that's grass clippings.
24:1?
Yeah, 24, from the carbon to nitrogen ratio. That's what microbes, that's the perfect one for microbes, but for compost you want between 20:30 is the one. You want that.
Nice.
I got a hell of a lot of stuff on that area. I can really go through the compost stuff. I'll get back to the next one I was going to show was the what is antioxidant rating? So I was hoping to lead into that. Oh, hang on, Main Green said, mainly mushrooms said, silica is based off what strain you are growing. Don't waste the money if you don't need it. Yeah. Calcium does the same thing. Silica, it's actually taken off the essential list and put on the beneficial list of nutrients of the 17 essential elements for a plant to grow off the silica.
So on the side of synthetic, you wouldn't need to do any of that. You wouldn't need to have a concern about extracting heavy metals or any pathogens out of soil, because synthetically you're only feeding what you're feeding or what you feel that you need to feed synthetically. So you're only adding what you add. You don't have the option or the concern to remove pathogens.
But how sustainable is it? That's the issue.
That's why we're here.
I take the leaves that fall every year off the trees and use them as fertilizer versus I got to mix some stuff and then the byproducts. What I do with those byproducts from the synthetic, making the synthetic nutrients. What am I going to do with that versus, I live out in the country. I just go down the street and ask the farmer for some manure and throw it on my compost pile and let it just break down over a couple of years. It's too hot coming right out, but
so
it's free.
What you're saying is at the end of the day, there's no real byproducts when it comes to synthetic, but there are plenty of byproducts when it comes to organic.
No, the production of the synthetics, there's heaps of byproducts for that. They've got to produce it. So there's all sorts of processes. There's transport processes. There's mineral costs to the earth. There's processes like that. So it's not really sustainable for going forward. Like for 10 years ago, people would say, yeah, but because we're getting all green in that, we've got to save the planet. That's a big no-no now for the synthetic production of the chemical fertilizer. Like, for instance, ammonia. That gets produced from lightning. So from the heat and the nitrogen in the atmosphere, when it falls and gets attached to the rain molecule, then you get little bits of nitrogen. That's how it comes naturally from the atmosphere. But they'll do it in the factories by just raising the temperature up with nitrogen and doing something else, and then burning things to get real hot and simulating the same process to try and reenact it to get the ammonium fertilizer out. As an example. But yeah, mainly mushrooms makes synthetic means salts. So there's a lot of salts and extra bits of mineral that you don't need or want, because once the salinity gets too high, things suffer, because once it gets up above, say, what, 1,500, 2,000, I should show that slide. I've got that slide ready. Things suffer, like, for instance, oxygen. We can't breathe once it gets below too much. We'll sort of, the same thing with the plants. They'll struggle with their nutrient uptake, and it's called salinity, when the soil goes, or the substrate goes saline, and that's from adding too much salts. And one of my lectures actually this morning or yesterday said from over-irrigating, you can create a saline effect. And how that happens is from irrigating outdoors, is you keep irrigating with your sprinklers, moisture will evaporate. The minerals that were in the original moisture, the irrigation water, will lay there. Then you'll irrigate again, evaporation, minerals will lay there. So too much over irrigating with evaporation will actually give you a saline effect too, which I found pretty interesting.
Like a suffocation.
It's, yeah, salinity, it's pretty cool.
And one of the things is, since I live out in the country, I have a well. I don't have city water with chlorine in it. So I'm watering my stuff outside with well water. It's already got the calcium and other base minerals in it.
Yeah, the well water is hard, because some people have good wells and some people don't, and some people have good luck and don't. So it really comes down to the mineral composition. So you'd have to get your water tested for the mineral composition, and then you could exactly know what's going on. But it also fluctuates from different types of the year, and different rainfall events will affect it. So by just getting one sample on that time and date and saying, yeah, sweet love, and this is what I got, it's only an instantaneous, tells you what it's got at that time type thing, if you know what I mean.
Sort of like a dry year versus a year where we have a lot of rain, when a lot of rain is just pushing all that into the aquifers. Yeah,
exactly right. Or if you've got someone up top who's just, they helicopter sprayed like my neighbours blimmin' do with their poisons, that did heavily that year, that would all go into the ground table water, and all of a sudden it would spike up with stuff you don't want. Or the salinity would go up too high with other different nutrients and runoffs from particular fields that get from. I was going to show you, I'll get the organic tomatoes versus conventional. So a study's been conducted by researchers at the University of Barcelona shows organic tomatoes contain higher levels of phenolic compounds than conventional. Phenolic compounds or organic molecules which proven human health benefits and are found in many vegetables. So that's one of the ratings. There's another rating there for ketchup. Yeah, phenolics. Polyphenols are natural antioxidants of plant origin and are of extreme interest because they are associated with reduction of cardiovascular disease and forms of cancer. So that's full on for us humans. So this is another organic plus. So it's not, just to do with it's other forms of health for us. This had salinity in it. This is that course that I was talking about. I just saw standards. Transition period. Everybody can transition. Takes 3 years to transition. No, not getting into that. Rotate crops. Getting into the salinity bit. Examples of crop rotation. That's organic. What's this? Now they've gotten up, it's talking about the yield, and you can actually improve your yields. You can use enriched vermicastings and enriched your inputs to organic inputs to get good yields like the synthetic or the chemical fertilizer people do, or very close. But the benefits are that you'll get more nutrition and better plant resistance, plant disease, and all that sort of stuff that comes into it. This shows that it's pretty similar. You can see the yield up the top here. So there's the chemical, organics. So it's similar. There's no fertilizer control. So there's an example. Costs a bit higher because organic is a lot labor intensive until you set it up. Once you set it up, it virtually runs itself, and you'll get a lot more. The cost will go down because of all the disease and pest control that you put in, and the returns will be higher. Okay, good. Online. Vertical farming. Okay. You can also do waterless mediums or hydroponics with organics too, believe it or not. This slide has it. Here we go. This is a nutrient solution in hydroponics with organics. So if you use filtered tea nutrients. So over on the left here, it shows the nutrients: pH, organic carbon, NPK, iron, copper, zinc, manganese, and then at the top, vermicast and vermiwash. So then it's got all the different numbers that they got from down the side here. So they've gone and used that, the vermiwash, so they've caught it all in a bucket. Oh, they caught it all in the bucket. That's hydroponics, sorry, return. But yeah, that's how they feed it. So you get your leachette or your vermiwash and put it through solution. And this is what they got out of their solution from their filtered tea newts. We're up to that slide before. Nutritional stuff. That was that.
Are you familiar at all with the Korean farming method?
Korean natural farming?
Yeah.
A little bit.
Yeah,
Yeah,
that's another good way of using what you have. Like
with their teas and their ferments that they do.
Yeah, and when you're one of these countries that are poor, you got to use the resources you have. You sort of like they're almost like organic, not by choice, but by what they have available. They don't have all these chemicals that they can use from other parts of the world because it's expensive if you're just a poor farmer.
Yeah, I think it's rad. I really like the teas and the way that they process the nutrients. The only thing that's not the best is the lactose. Some of the bacteria that they focus on is in the lactose genus, and that's a heavy. It's non-symbiotic. It puts out a nice looking biofilm with heaps of antibiotics in it, and it doesn't work well with other microbes. So if you want to get a high diversity of microbes in your substrate, that's not your friend, if you know what I mean. They've used that. It's actually quite a good preservative, different types of lactose.
So you're actually harming some of the good bacteria because of that?
Yeah, you could be. Yeah, you could be, because the bacteria, they've got different forms that they go in. Like, are they competitive? Are they symbiotic? Are they pathogenic? Like that. So you've got to see, do they work with each other, or are they going to cause problems, or are they going to eat each other, or are they going to harm each other? That's very hard to work out, to be honest. So that's why you'll see a lot of the microbe, like the great white shark thing and stuff like that. If you were to test it, you'll find that it mightn't say what it does on the back for that reason. That's why I source my microbes individually.
Great white shark microbes carry a lot of microbes in the kingdom that will harm and seek out other microbes to destroy. So specifically, they put that in there on purpose to kill harmful microbes. They do that, but you don't know what they're killing. So at the end of the day, I don't recommend great white shark, because they may go rogue and kill something that you have no clue what they're killing.
I only recommend great white for compost heaps. So to get a good diversity in your culture, in your it can work itself out. So if you're going to stimulate that, in my backyard I made a dozen massive compost heaps and inoculated that. So that had time to go through and all its process. And 6 months' time, then I went and dispersed it all. And that was a good way of sorting out the good and the bad and what's going to work with each other. So I gave it heaps of good, what I thought was good, and it can work with itself. And then you should see my, I haven't seen what do I call it, when we go for a field tour.
Yeah. Well, 6 months is a half year. And a lot of people are just starting out and they want to know what to grab in the next 15 minutes. Unless you can like single out those microbes, which is millions and thousands in the kingdom of this. I mean, it's a lot. It's a lot of microbes to consider. I just know for a fact that Advanced Nutrients has a finger on exactly what to use. I swear by it. I swear by this product. When you add any kind of nutrient line to these microbes, they are broken down and they are used. And it's just, you can see it. It's next day action. It's the greatest I've ever seen. And they swear by the amino acids. So when it comes to microbes, a lot of people, they understand microbes for what they do. But when microbes attack an organism, they eat it and they poop it out. And when they poop it out, they poop out certain enzymes. And those enzymes can be bottled as well. So when you go to a hydroponic application, you don't need microbes. You just need those enzymes that the microbes poop out. And in that case, you'll get the same effect. Those enzymes will still break down certain materials, organic or inorganic, to help your plants absorb them readily and easier. So you have to.
There's microbes that fix nitrogen. There's microbes that solubilize phosphate. So the microbes do a lot more than just the enzymes. That's how the compost heaps break down. They get saprophytes that degrade things, put out acids. So the fungi. So there's they do a lot more than just the enzymes. That's just one of the tasks that they do. So you can get enzymes that are specific, like some of the ones that I use. They might use nitrogenase. They got protease, which is very handy enzymes. That there's a few questions here. FM says, how do we find the right balance between adding microbes and adding nutrients? Adding microbes, get as many good ones as you can. An example of that is in just out of Anchorage in Alaska. They've got the world's biggest pumpkins, and you've all probably seen them or heard of them. Why is that? The reason is because they did a metagenomic study of the microbes in the substrate, which means that they study every single microbe. They found out that they had a species of over 20,000, which people usually get. If you got 4,000 or 5,000, you're doing really good. They had over 20,000, and they were all working within each other. So they've been for so long and so good that they do all these right things, and that's how they got so big. I use microbes that specialize in phytohormones, so they'll do two tasks for me. They might kill things, and then they have to do phytohormone release. So that's what mine do as well. So that's why I'm up there with the world's biggest carrot at the moment after 7 months of growing, because I've chosen microbes that produce gibberellic acid, and gibberellic acid swells fruit. If you want your flowers or fruit to be larger, you use gibberellic acid. And I don't buy it. You can buy GA3, GA4 if you want in the powdered form. Dilute it. It's water soluble. Just put it in your spray or in your nutrient solution. But my microbes produce mine. Over. That's about the microbes. And adding in the nutrients, be careful. It's salinity. Test your substrate. Take some soil out of the ground, put it in a bucket, test the water before it goes in, and flush water through it, and then see what water comes out of it. That'll give you an indication of how much salts are in the substrate. You'll be testing your EC meter or your ppm, because your EC, you times it by 650 or 700 or something to get ppm. And if your ppm is over 2,000, you're in big trouble. Not big trouble, but you're starting to get problems, which is called salinity. So that's with nutrients. So you can't just keep adding and adding. It's the balance. And that's why organics, it's immobilized in organic matter. So the leaf under the ground might have heaps of NPK in it, but it's bound up in the material, where you're giving synthetic, which is released instantly, sitting there. So organics has a forever supply of nutrients in that sense, as long as it can be broken down by the microbes and the fungi. Over. Hope that one helps, FM.
You're right. As long as you're feeding the organics with the microbes, it can break down everything as long as the microbes are there. So that's why I put a vote in for synthetic, because if without the microbes, it's not possible, and the microbes are organic. So for those that ask me the question a lot, can I use these microbes in microbes and organisms that are live are 100% organic. So I have not seen any inorganic microbes yet.
There's even microbes that break down plastic. There's a couple I've got some that break plastic down. So if you want to contact your government, you can go and get grants off your government, introduce these species that I got, culture them right up, put them in the plastic, put some water in, and bang, they'll do their job. And the government
and that would be great to introduce to water filtration companies. That I witnessed one in like the 8th grade. I went to a science trip project, and they filtrate the water by just introducing microbes, and it's like this brown film on top of the water, and they say, hey, that's bacteria, and it cleans the water for us. We don't have to actually use a filter, we use bacteria. So these bacteria that you have, we actually use them to filtrate the plastics as well.
You know, when you
microbes do not poop.
That's what I was going to say. You went to a sewage treatment plant.
Yeah, I did.
Yeah, but you can drink the sewage water these days because, like you said, it goes through separate processes. They've got. I know a fair bit about. A few of my courses were actually on that. It's just a stage, like people's tanks, sediment. They got those 5-stage stuff in there to get rid of their poop. But microbes do control it all, like mainly mushrooms said. And I work on microbes controlling my environment for meat. Like I've got nitrogen. Use 5 different types of microbes that pull nitrogen from the atmosphere, exchange it within their metabolism, and they poop, like you said, they poop it out, a readily a form of nitrogen available for the plants. I use 5 types of nitrogen fixing bacteria. I got phosphate solubilizing bacteria and phosphate mobilizing bacteria. And then it keeps going down the list. All these different types of microbes you can get individually to work for you to do 1 or 2 tasks. That's what I specialize in, I suppose. And now I'm getting into the psychrophilic temperatures, which is why can't we grow in winter? Well, we can. The sun's there. Why can't we? Well, it's the temperatures. Well, we need processes to cycle. They've got nitrogen-fixing bacteria that work in the Arctic. So you've got to go and culture some up there, and this is new technology where they're getting scrapings off underneath the glaciers, for instance. That has bacteria that grows and works in those cold environments. Our bacteria is in the mesophilic range, which is from 20 Celsius to 40 Celsius. So what's that? 60F to 90F or 100F, something like that. And then you go on the thermophilic, which is over that again, which works in your compost and breaks stuff down. But this is under that 60F, 50F, which is, your non-growing area. So that's something that microbes can do for me too. Over, that'll do. I can go on to
an example of that be the mycelium. Well, you probably don't know a whole lot about snow, but the mycelium that grows under the snow, it's usually like one of the first things I see when everything starts to defrost. A nice layer under there that developed over wintertime by itself.
That's a rad example of a psychrophilic species of fungus. So you could, that's pretty good, mate, because yeah, that's an exact example that the scientists are actually looking for at the moment. Great. I was just thinking I nearly want it but I'm not in the area to do good experiments at the moment. I did have some snow, believe it or not, a few weeks ago. Whew, I went snowboarding in my front yard.
Oh wow, yeah. I get snow at last from November to our last frost date here is May.
Oh, you're up there near Canada.
Yeah, I'm probably about maybe 400 miles from Canada.
Nice. I spent 5 winters in Canada. I love it. Hi to all the cool Canadians. Yes, things break down on getting as possible. Yeah. Yes, the top dress is a way to end. Nearly caught up. Oh yeah, thanks for the nice words, mainly mushrooms. There's Lene. Hello, Lene. Look, hello, Lene. You can see me for once. These azos and micros worked okay. Yes, the azos are the nitrogen-fixing bacteria, and the microbes are the phosphate-mobilizing bacteria.
I've used micros as well.
And when you get into it, the azos, like Azospirillum, is the genus that it will come from. And in that, you got Lipiferium, which is a species that is used I'll have to look up this one. But there's another species that you can get. It starts with B, and that uses indole acetic acid as well as does the same job as producing nitrogen. So that's what I'm into. You get the microbes, but you also get them doing two things for you. That was a good example. Thank you, mainly mushrooms. FM, compost is a lifelong journey. Most people want to just buy bags of soil. That's right. And just like Loki was saying, his neighbor throws it out. What?
Yeah, it's kind of weird going over to your neighbor. Can I have some of your cow poo?
Yeah.
Okay, I'll take it. Or horse manure.
The only thing about that, if you were going to jump onto someone else's, is be careful what's in it. And to eradicate any problems, you want to get it up to that thermophilic temperature of about 65 Celsius, which is 140 Fahrenheit.
Oh, wow.
And then stay at that for about 3 days, and that'll break down the seed material and all the pathogens. That's a way of pasteurizing the compost heaps. So that will make it all clean to use for the following season.
So I can actually put straw in there, right? Because straw gets hot when it decomposes to help that reaction to happen.
That's a lot of the nitrogen factor. So you want to make sure you see your carbon to nitrogen ratio is good so that it does allow that to happen. That's right, mate. Okay. That's where the 1 is the 25 is to 1. So 25 is carbon, and then the 1 is the nitrogen. And then you want to make sure that that ratio that's exactly the right of grass clippings. So after you mow your lawn, if you just put it in a pile like I do, that's doing its job. You'll open that after a few weeks and you'll already see there'll already be color inside of it. And that's probably the fungus starting to throw spores around and do its job, like underneath your snow that it grows.
Okay.
Even better, you can get all your heaps that's growing and then just make up a little tea solution. So you might get your beneficials. You make up a small amount of tea, and then you just go and put a tip of this across the heap, in each heap, and then you've just gone and inoculated this little tiny bit that you put into this bit across your mulch heaps, which is going to be therefore mulched across your big fields in only a short time. So in other words, that's how to multiply it very fast.
Wait, so at the end of the day, we're just highlighting the things that make organic. We're not really comparing the difference between synthetic and organic. So right now, let's focus on the points that make these things completely different, because in my grow, I introduce microbes and all the things that break down elements for the plant to completely solubilize. Like the plant can just absorb it the way it needs to be absorbed. I introduce microbes that I believe can break down the inorganics that I produce or provide. Sorry.
The synthetics supply the 17 essential elements that the plant requires for its growth and development, but that's all it supplies. It doesn't supply any of its pesticides or its protection or its and in that that's called your secondary metabolite profile. And with that, the plant with organics, it will be grown looking for its nutrients, so it'll be putting out chemicals to try and find its nutrients. Through its exudates and its roots, it puts out acids, and in these acids there's protons, hydrogen plus ions that go in there which want to swap with other cations. That's how it gets its elements through that, and it really can attract the elements that it requires because it's not been bottle fed, as you could call it. With the secondary metabolite profile, with the organic one, it will be putting out more terpenes and phenolics to try and attract the beneficials that it wants and repel that the insects it doesn't want, where the bottle-fed one is just happy to go along and just do its service and continue its growth and development. So that's one of the reasons why you get a lot more of a profile with your
Is that through the roots or through the plant?
It puts it out through, well, mostly through the air. It can put it out quite easily, but it will put out signals through the roots because in its acids, it could change its profile through its exudates in the plant's roots. But it's more so, I'd more so say like 95% it's in the phyllosphere, which is above the ground.
So the answer would be, how are those signals retrieved?
It's through allelopathy, it's called. The plant has receptors in its tissue that when the signal comes through the air, it locks on and then it sends a signal down. And then to make that signal, for instance, jasmonic acid is a molecule that the plant puts out when it's in defense. So it makes methyl jasmonic acid in its tissue, and then it emits it. So the methyl gets volatile and it gets emitted into the air, and then that volatile methyl jasmonic acid molecule gets put along and bang into the plant. It locks into its neighboring plant, and then it goes and reacts on its pathway then as jasmonic acid. So it can warn its neighbor of what's going on.
Yes, jasmonic acid is a hormone that the plant produces, and it's synthetically produced as well. And it stimulates the growth of left to right. It makes a plant grow wider. So if you introduce synthetic jasmonic acid, it stimulates the hormone to make a plant grow left to right, not up and down. Like up and down is you mentioned it earlier, the other acid that the hormone produces. But at the end of the day, we want to understand the difference between synthetic and organic. Is there a real advantage from one over the other? Because if I can introduce certain microbes that make my synthetic grow just as effective as an organic grow, why would I choose organic?
That question. Well, you can introduce a lot and you can mimic an organic output of your plant. So if you were to go and test, you can. It is possible to do that, but it's not sustainable, and that's the whole reason why it comes back down to the sustainability. But on affordability, if you've got the money, you can. It just takes a little bit more effort. You can add, like you said, even synthetic jasmonic acid. You can spray on it. You can add synthetic gibberellic acid and spray on that to swell your fruit. There's numerous synthetic ways you can do it to mimic these things, but in general, you'll have to put you'll have to put that into your program and or go organically. And the difference with the organics is you get these other ratings too. And this is what we'll go through now. So I have sort of gone on a bit about the, on a bit about the questions and stuff, but here's some back of the slides in the literature about why the organic produce agriculture is healthier and beneficial for us. Thanks for that, organic one. Thanks for the content, it says. Keep up the good work. Thanks, American one. Come on, you buddy.
I think we touched on last week about the there's a taste difference. You said there are some tastes that come from organic that cannot be perceived in synthetic.
A taste difference. Well, that would be put down to the flavonoids, the different flavonoid content that's in the secondary metabolite profile. So that would be testing a little bit higher in the organics. And that is one of the ratings that will go through the ORAC rating, the organic rating. And then there's a catechin rating too, which is, they use a lot in the tea, which is to do with the mineral content in that as well. And you can see the difference of the conventional growing with the organic growing.
Okay. And also, if you don't till the soil, you know, there's plants have a network that can go on for miles of undisturbed soil where it communicates.
Yes, that's right. Yeah, tilling the soil makes a big difference. There's conservation tillage, which is up to 10%. I think anything under 10% tillage, and it's called, if you only interrupt the soil 10%, it's under conservation tillage. And then it goes down to the no-till, which is obviously, you know, the no-till. But exactly right, mate. You're disrupting the biosphere underneath, which has already established itself. So when you get it out, keep the pods. The pedology is the production of soil. And when it gets into its aggregates, it starts to bind up. That's when all the microbes and fungi have done its thing, and they're creating little homes and good. So when you break that apart, it splits all that up, and they've got to struggle again. So keeping all the little aggregates together is beneficial. Like when I just did my tilling, I tilled it and I got some chunks that are that big. I'm not breaking them up. They can just stay in there a little bit and do their thing. As an example for the tilling thing. You've got some good questions, mate.
Yeah, I've always wondered why they would say no-till. Like, well, what's good with no-till? But yeah, you're disturbing everything. You have to start all over again when you disturb the soil. Yes.
Yeah, and depends how much you disturb it. It's you might split colonies up that are really good. Then it might introduce a colony that might be too dominant and kill off that species that was so beneficial there in the first place. Where if you keep them as their pods, their aggregates that get together, more than likely they've established their position within that ball of soil and they can maintain doing their thing. So if they were to split up or to get a worm comes through and grabs and vectors out to other spots, they can still continue multiplying, doing their process for you.
And synthetically, would this be a problem? Probably not.
Well, if you were synthetically transvectoring microbes, is that the question? No, because the earthworms will still work in synthetically input. Microbes will still be all right as long as you don't poison them. Microbes turn off too. So if you've got too much nitrogen in a substrate and you want your nitrogen fixing bacteria to work, no, they don't work. To make nitrogen fixing bacteria, you put a media into the culture, the Tetri plate that has no nitrogen in it, and then they'll start and multiply.
So say I had a sacrificial field with excellent soil, great network, great mycelium. Can I take some of that soil to reestablish or start a colony inside?
Yes, you can. Disperse the good soil you've got around. Like the soil that I could produce here, I could nearly dig out a bucket and sell it to a neighbor for $10 type thing, you know, because it's that beneficial.
Okay.
Yeah, it's a good way of inoculating and getting your goodness out to other spots that aren't as good. But pH is everything. So make sure the pH is one of the first things that you're going to check in your field. For per acre, it's 10 points per acre.
Okay.
it's 20 points per hectare that you're supposed to get accurately to have a good description of the pH. And that's in a zigzaggy motion that you take your pH reading. So after you've established that, then you get it up to the level or down to the level that you want. Then you can start. So otherwise, microbes and grasses and seeds and all sorts of things, they don't turn on, turn off, and you'll be struggling too much.
Okay. Have you heard of using ascorbic acid to moderate your pH? Vitamins specifically? Just because I haven't done it doesn't mean to say you shouldn't do it or you shouldn't try it. I'm not the blimmin'. I only got education. I only got experience in my field that I have. So science is huge. So putting these experiments and you doing them yourself, you tell me as well. But no, I have no experience and no knowledge in that area for that to happen. I'm gonna get out a try.
So what's the ORAC rating this person keeps going on about? Well, it's the oxygen radical absorbance capacity. And that allows us to compare the capacity of individual fruits, veg, produce, and other antioxidant-rich foods. So the higher the ORAC value, the more effectively it can neutralize free radicals. What's these free radicals? Well, they are reactive oxygen species within our bodies. When we produce stress, we produce superoxide dismutase, hydrogen peroxide, other oxygen-rich molecules that attach on and break down and kill other molecules that we have. And that's where we need antioxidants to get rid of them. So that's where this comes in, that ORAC rating. So there's your vitamin C, what you just said before. As an antioxidant value, I'm going to skim across these because that's pretty much it. Now your polyphenols, that's a group containing, it has its benefits too, involved in the antioxidant rating. There's all different measurements that they've done to bring out this number. And here's some ORAC values in fruits. So this will mean a lot to you. So prunes is very, very high, 5,700. Cranberries, 1,750. And then plums are 950. It goes down to bananas are 200. Apples, 200. Peach and pear, 150. And that's from 2005. And remember, this rating is in general. So this will change per location, per species, per growing practice and all that sort of stuff too. But it's just a good generalised.
You're not going to make me start drinking prune juice, are you?
No, it depends. Do you need to improve this in your diet? So if you need to, yeah, maybe. But it's just good to know though.
Yeah.
And here's one doing it. Spinach is so that was for fruits. This is for veggies. Spinach is high. Brussels sprouts, alfalfa, 900 still. Goes 700 to bell peppers and onion, 450. Corn, 400. Write down carrots, 200. Beans, 200. Tomatoes, 200. So that's an ORAC. Comparison between organic and inorganic vegetables for antioxidant contents. So there's the fruit and veg there, substances in the middle on the results. Here we go, JP, look here, this is what you want. Higher in organics, similar in tomatoes, higher in organics, similar, higher. So nearly a 50% spread there. So the debate continues. Yield and total phenol of tea grown organic. So chemicals or organics. So that's the yield, so a bit higher, or pretty much the same, you could say. Phenol content, look at that, 50% higher. Catechin content, wow, 300% higher, times 3, isn't it?
Yes, I see that.
So there's a little bit of difference.
But the question is, now, those synthetic nutrients are knowingly and willingly known as synthetic. But what about the soluble, organic, synthetic? That like these nutrients are being called organic, but they're 100% soluble and they work in cocoa and soil. These nutrients are at the front line of the industry right now because I can just have 100% cocoa perlite, and if I go organic, there's no possible way for me to be 100% organic with cocoa perlite as it would be in soil. So my real question is, are the soluble nutrients that claim to be organic as good as soil organics?
I don't know how they can claim to be organic though, because
It's
an organic
so
soluble,
it's so many nutrients that I've tested that have very, very good results, but I've provided a high amount of microbes while testing this theory, and I don't know if the microbes are the providing factor.
yeah, the
And
micro. Sorry.
because the microbes may be just what made the nutrients is the organic but synthetically applied nutrients so good. I have no clue.
I think the manufacturers are doing their manufacturing bloody jargon on you, because to get a calcium powder, it's got to be processed, and that's synthetic. So to get calcium organically, that's immobilized and it's bound up in tissue, for instance, in leaves, as an example. Like you might buy neem seed cake meal, or you might get alfalfa sprouts, or you might get stuff like that, and that's got the calcium in it. And they tell you in your NPKs, like of what's high in calcium.
So what you're saying is these organic synthetic nutrients, or the soluble organic nutrients, they still lack calcium.
I don't think they're organic. I think they were produced synthetically.
I mean, I have a belief they are, but my understanding is if they pass our organic rating, then there's nothing synthetic about them.
Yeah, the organic rating, I think, is for fruit and veg, for seeing how high that number is. So just an indication of how healthy it is for the human if we take it. And here's an example. I've got a chart here of my NPKs of organic inputs, and of cane molasses has a calcium of 0.8. So if I wanted to give 0.8, NPK, cane molasses, raw cane molasses has 0.8. Dried yeast, 0.05. There was one that was higher. But yeah, that was my newest one, was dried yeast. I was quite happy with that because that's got a NPK, dried yeast, organic, 828.
Dried yeast, organic, was 828. But what about inorganic?
That's insane. So as an organic food or an organic input, that's rad. I learned that from my industrial biotechnology.
So what's the numbers for inorganic?
For who?
Inorganic, non-organic.
Oh, yeast is a it's a microbe. So yeah, it's.
So it will produce the same numbers whether it's organic or inorganic.
Oh, that's a question. That's a good because no, they got different strains now where they produce for the lab that they are very high. They're called industrial strains. So there's two types of microbes that you get. You get a wild strain and you get an industrial strain. And the wild strain will give you who knows, or it might give you that. But the industrial strain, which I quote these numbers off, should give you the numbers. And they're the ones that go. So if I was to go and put my big vat out and go and multiply it from my Petri dish to my flask to the vat, I'll get those numbers at the end. That's why they give out the industrial strains, and they cost a smidgen more when you go and buy them. And
so, in summary, let's like give the laming, like let's give everyone in the comments something in summary. Like in summary, we do understand that organics versus inorganics is a constant debate, but what is it in summary? Very simple. That will make you choose one over the other.
Two things. The way the plant grows, it'll defend for itself and it'll be able to tackle hard times. So it'll take care better of pest and disease, and it'll be able to get through water, drought, stress times better. The other reason that I would like to go organics is the secondary metabolite profile is higher. So if I'm extracting it, if I'm inducing it, whatever I'm doing to that plant at the end, I'm going to get a better, healthier level than someone that's to bottle feed it or synthetic. That's my two real reasons for me choosing it, and that's all this literature will explain that. But you want a summary.
Organic is just easier for me. It's just
also sustainability. Sorry about that. Sustainability is a big thing for me, being caring about the environment. So that's probably the third thing I should have added. That that practice it costs too much money, but it does make jobs, but it's not sustainable. It's not good for the environment. Over.
That is a big factor. Sustainability is in organics actually ruin the soil. It actually ruin the earth when you get synthetic nutrients and you apply them to a crop that's grown outside. It's absolutely devastating to the planet. But a lot of people aren't growing outdoors. We're growing indoors in tents, small concentrated places where these inorganics won't affect the atmosphere.
If I had to choose, like if I was struggled for size and space like that, I think I would go synthetic. The reason being, for organics, it's hard to get the inputs and hard to manage without a little bit of space. Like for me, I make my own compost and it's a lot easier for me because I've got space. But
outside.
If I'm indoors, if I've got a unit, I don't think organics would work for me because I'd have to, hey, don't get me wrong, you can do it with neem seed cake, alfalfa meal, oyster shell meal, langbonite, humic acid, all these different bags you can buy, and it still works pretty good. But in general, it's a lot easier to get one bottle and go bloop. So because in a unit, you haven't got much space. And the outcome you're going to get, if you do a pretty good job, you're going to get at least 3/4 of what the organic grower goes. If you're a connoisseur and if you're going into the next cup in your local area or the state cup, then you'd maybe transition a little bit for organics and put the effort in and buy all the extra microbes and stuff like that. But in general, there you go. Does that make you happier, yield source?
No, it's not it's not a happy situation. Let's decipher it. So why would you in your next cup go organic? So if I'm a synthetic grower and I've been growing synthetically for 10 years and I don't see any issues in my harvest, why would I go organic for the next cup? Is there something there that I'm missing that you can put a pin on?
The secondary metabolite profile.
The secondary metabolite profile. Please explain.
When the plant defends itself, it expresses its terpene and flavonoid content. So if there's all sorts of bugs around, it's going to express a lot of that. And you're going to get a very high terpene flavonoid content when you test it. But if there's not in the air, there's no need for it to put it out. It's just going to kick on doing its growth and development. That's one massive thing that produces a secondary metabolite profile.
Wait, so you're actually explaining to me about stresses in the plant, but
yes,
how can we differentiate that between a synthetic nutrient line or an organic nutrient line? I mean, you're telling me that the plant will express these things, but I don't see it in these applications.
It's for the person to like for the user. I agree. It's hard to bloom and tell, but if you've got in a cup against other people and then they test it and they put out the numbers, or actually you do it side by side where you'll do one where you'll give organic inputs. Maybe wait until you get some bottles of organic stuff, some bags of organic and some good substrate soil, and just do a side by side and get the tested. And then you'll slightly see that the numbers are just a smidgen higher. But the numbers are I'm talking small, like it might go from a 2% profile to a 3% profile. So it's minimal, but it is an amount that will win you a cup, and it's an amount that's higher, and it has, if you're an extractor too, it'll get more benefits for the taker, for the person that takes the extraction.
So the reason for our conversation is to understand those things, those small hiccups that you believe will give an organic grower the advantage in a cup. To be able to apply that shit, to be able to apply it to synthetic. Yeah,
that's right. It's just it's a smaller amount, but for the healthier person too, it'll save you a little bit less money because you're buying water when you buy those nutrients. You know, for me to get a big bottle because I do farming, so to get some NPK, you get it in grain or granular form, and then you'll dilute it in water, then you put it in a bottle, and then you'll sell it as the hydroponic people do. It's 99.5% water that you're buying. So it's not the sustainable best, but it's an easier option. And that's why people go for the synthetics, because all they got to do is follow a program and then they'll get an outcome. And that's good. But for a connoisseur or for the person that's got the time and effort to put that bit more, you just get that little bit extra. And then you've got the pest and disease help resistance. It helps a little bit in fighting off pest and disease too by the organic growing, because it's not bottle fed. It puts out all these allelopathy, terpene profiles, different flavonoid contents that's to try and attract things and push stuff out. So that expresses in the tissue too, that you'll get when you harvest.
Personally, I found that organic growing has attracted more pests than synthetic growing.
Maybe because the synthetics that you're using has something in it that works, like what's an example?
That's just telling y'all, even the bugs won't eat that stuff.
Yeah, that's right. Thank you. That's there you go. That'll be. I don't know what else to say. That's a good one, Loki.
Yeah, that was a good one.
The only thing that when you use the synthetic fertilizer, the plants get used to being bottle fed, so they haven't activated the pathways that are primed for the defense pathways. So when they have to go and activate those pathways, they go, "Oh, Jesus, what? Now I'll have to try and do it." Unless your genetics, I code my genetics to have pathogenic resistant genes, so they're ready to go. So you can prime your genes to make them active in that sense, but it'd be good to test genetics like that against organic genetics to see if they do activate at a similar sort of a rate.
Yeah, it would be.
It's a similar way by imagine a bodybuilder that keeps getting fed and getting fed. He's got that's it. He's got rad growth and development, but it doesn't do anything for his immune system, to his looks, to his anything else like that. It doesn't help at all. But it's rad to bulk up and get something big quickly. It's a similar type of a thing. It's over.
It would be great to simulate those experiments for that in that particular area of of what we're looking for. But at the end of the day,
Yeah.
I noticed in how I've grown and how I've been growing that we can simulate these same things with the minimal cost of the problems. It's like organic can pose so many issues that you have to address, but if they're not there, you don't need to address them. You don't have to address the pathogens because you didn't introduce them organically. And
No. Sorry, keep going.
no, I'm sorry. Go ahead.
On an indoor garden, it might be different because you've got it all virtually closed. You're kind of growing in a lab, if you know what I mean. And that's what people try and create. So it's virtually blocked off. But I put all sorts of hepa's over the indoor filters and outdoor indoor filters and things like. So it's a smidgen different with the bugs. But if you do get bugs, it can really take off. That's the only bad thing, because you're coming onto a virgin plate, and one thing can just all of a sudden it's just off. So if you get something vectored in, some human that comes in, some bloody tester person with their big coat, we just come from another farm, it's okay, we can wear the same gear. No, you bloody can't. But as an example, things get vectored in, bang, it's all on. So that's a downside to
The darndest thing that I've seen is my buddy Gluck. He uses carnivorous plants in his indoor garden.
That's flawed.
That's some serious payback right there. He's got this little red thing in there, and they get sucked in there, and they never come back out.
Yeah.
I like what Teo, American one, says about the synthetic waste ends up down the drain. So it comes back to sustainability is another big plus. This is a debate, so we're just ticking the sustainability bit sort of on that comment. Thank you.
A well makes you very aware of what you're putting it down the drain, because pretty much everything that goes down my drain is eventually going to cycle back into my well.
Yeah. Yes, it is hard, especially if you do a high volume water flush. It's not good. But yeah, the sustainability is just a fact you can't get around these days. But big marketing doesn't care about that, because they've got to make money somehow. They've got to pay people to get it out of the ground, to put it through their processing treatment plants, to store it, to transport it, for retailers to sell it to you. So that's why they don't really want to tell you all these good bits about it, because it's going to eliminate a lot of practices. Even in Australia, I'm sourcing large amounts of organic inputs, and the agricultural supplier, I said, where are they? They said, organics is new to Australia.
It was organics way before there were synthetics.
So, yeah, we're down under for reasons, mate. We got some bloody screws loose, they reckon. So it's just incredible. So I tried to source 20 kilos of neem, and it's going to cost me $100. It was really hard. I was going to nearly import it. I was going to and sell it here locally. It's a niche market at the moment, selling the amendments for organic inputs in Australia. There's no good suppliers. But I don't know where I was going there. Sorry.
Before I met Source, I was totally ignorant of microbes. I'm like, I knew what microbes were, but I did not know how to apply this to gardening. Just like people buy Gaia Green, and then they don't feed it any microbes, and then they wonder why their stuff doesn't grow. We don't know about microbes.
I sort of nearly specialise in microbes now, not plant science, for that reason, mate. Now I'm finding more, because you're that interested. I'll share this as a spin out. This is my list of my personal microbes that I'm working with at the moment. And then it gives a summary right next. Can you see? Oh, yeah. Microbes. So you can see that they do two different things. So I might have the phytohormone, like Azospirillum, the perferium, is a nitrogen-fixing bacteria. It also produces gibberellic acid, remember, that swells fruit, and cytokinins, and it works within plant tissue. But What was my whole point in doing this? This is the list. You can see they all produce hormones, and they all do a special pesticide, nitrogen, phosphorus, iron chelator, silicon. So all different things. So just from urease. Oh, here's a good one. Some enzymes you're talking about before, carbonic anhydrolase. It absorbs CO2. That's going to save the greenhouse gas. That absorbs CO2. What a spin out. So yeah. This is a good one. Cellulase. So that's a good one for your compost heap to break down all the cellulose that's in the plant material. Or chitinase. That breaks down the cell walls of insects with chitin. They made their cell walls of chitin. So you put Bacillus fumilis as a antimicrobial, as it is. And that's the reason why. But there you go. That'll do. So microbes are everything, mate. And the more I get into them, the more I realise that they control our environment and our humans. We have 90% cells in our bodies and microbes. You know that? 90%. So of all the foods that we eat, they all affect our microbes inside. It's rad. And these courses that I focus on are microbe orientated, and the more I see on the microbes, the more of them, they just sink into me. So I'm really up there on the microbes if you've got any microbe questions too. But that might be nearly a next show. I can really talk about this all day.
Does peroxide kill microbes?
Does peroxide? Yes, it does, massively. Yep, that's one of the big downsides to it. Yeah, unfortunately. So people that say they put that through their substrate, yeah, it's good at neutralizing and killing the problem in the substrate, but it kills all the beneficials too. Spring tails or hypoaspis or other detritus running around the mulch. Yes, you see spring tails, they're always good. The hypoaspis are really good to eating larvae in your substrates. That's a IPM tool that you should get. Sorry, people. And the only other thing that I was going to conclude on was the free radicals. Get into that. I'll get back into that. There's chat here too that I haven't gone through. I'm sorry. All right. There you go. There's another culture about
the rice water.
Yeah, pasta wash or rice wash. That's got a lot of nutrients in it that support culture. And cane molasses is another really good input that supports culture growing as well on its own. But we're not talking about it. Sorry, I'm off point. We'll go back to share screen and wrap it up. So that was where I was up to, the organics. The growth differential balance hypothesis says this is the conclusion. There are two leading theories about why organic fruit and veg produce higher antioxidants than conventional counterparts. Here you go, mate. Trends in plant science. This is from that. So the stress can be caused by environmental factors. And then because the crop's grown organically, it puts out those traits to combat the stress and attract the stress, which creates these molecules. There you go. That's what all that summary is. You can read it if you want. There's the paper later on. Where's the second one? The growth differential. And the second one is on the nutrients. Why the highest level, very low levels of nutrients will also result in low level of antioxidants because there will not be enough resources for creating secondary metabolites nor plant growth. Basically, at very low levels of nutrients, you will have an unhealthy plant. See, the secondary metabolite profile is the key. That's the bit that gives you the higher terpenes and flavonoids and that sort of stuff. That's the cup winning difference if you want to have a cup winner. The intermediate nutrient content are similar to those found in organic farms with higher nutrient contents. Thus, intermediate nutrient levels on organic farms should result in crops with higher antioxidant production than crops grown on conventional farms with high nutrient levels. And this little chart shows it. You get to a level that's a level where it reaches too much. I can't remember what it's called, but that chart shows it. So if you put too much into it, you think, oh, can I just keep giving it? You're going to create yourself a saline effect in the substrate, and it's going to do an opposite type of thing, and it's not helping with your growth and development. And that's that one. And this just goes on about those free radicals, about that why you have antioxidants, because they're the molecules that you produce in your plants, and they will get with your free radicals you produce in the body. Especially more so, this is for extractors or people that ingest their fruit and veg. So I'll just throw through these. There's only 10 here. Antioxidants help control cancers as well. Cardiovascular disease, asthma. The polyphenols, their health content. So you get these things, these antioxidants, polyphenols, all are in the secondary metabolite profile. They're minerals, they're not, but the secondary metabolite profile produces them. Actually, some microbes we're not talking about microbes. So there, you've probably read that. Vitamin C and A, you know about that. So yeah, your plant will also produce more vitamin C and vitamin A, which is to do with the secondary metabolite profile. So that's organic food for health. There you go. And pesticides was the other thing. So that sums it up, I think. What do you think?
I think we still should be thinking.
I'm smarter than when I started.
I'll keep going. There's plenty, as you said, I tried to summarize the hang out of that.
Yeah. How do you feel, Loki? Because you are loyal to the soil and have this, like, I mean, not only does it like push you toward what you're doing already, do you have any insight of why it would be a difference?
No insight on why it would be different, because nitrogen is nitrogen to the plants. They don't care. But your palate, if it's going to affect your palate, I want something that's going to please my palate versus add something there. Because like I was looking at one of my labels of my nutrients, it was like 0.5% nutrient and it was like 95.5% water. So you're kind of getting conned because you're buying a whole bunch of water and you don't need it. They can concentrate that and you just use a little bit and add your own water.
That was going to be a show coming up, was making my own organic liquid inputs.
Like ferments?
No, like
whether it's organic or not. This is the question, because I'm quite sure we started this conversation on whether
kelp. Okay, I use kelp.
We started this conversation on whether certain calciums are soluble or insoluble, whether they're inorganic or organic. It doesn't matter about how soluble it is. We were talking about the inorganic and the organic material that is absorbed by the actual plant itself. So I want to get to the nitty gritty. I want to understand at the end of the day, if I introduce organic soluble nutrients or inorganic soluble nutrients to the same medium, no matter the medium, because we're not talking about soil, we're not talking about cocoa, and we're not talking about hydroponics. We're talking about the solubility, how much of the nutrients will be absorbed, inorganic soluble to organic soluble.
The only kind of soluble organic nutrient I know is cane molasses, because if you put that in water, it might dissolve a bit. That's the only thing I know, and that's got a NPK of 0.5, 0.07, and 2.2.
0.5, 0.07, and 2.2. So when we have when we have a nutrient line like advanced nutrients that says they have a soluble, 100% soluble nutrient, which is called the OG line of organics. Is it absolutely organic, or just because it's soluble makes it inorganic?
It's organic supposed to be attached with a carbon molecule. That's the actual definition of having organics. In other words, it's bound up in organic matter. It's not as a molecule on its own. It's not separate. Like vitamin C is just sitting there as vitamin C, as that yellow powder. That's not organic because it's not attached to a molecule. Even if it's sourced organic, that's what they reckon. If you put it in the definition of organics, it comes.
So there's a so what you're saying, there's a molecule missing to call it organic?
Yeah, because it has to be carbon or natural.
Carbon or natural?
Yeah, because in other words, it's been processed. If you have to process it, it removes the carbon molecule to make it more refiner and more purer, and then that's the synthetic version of the version.
My question to you: does the OMI or the OMI label, do they look for that carbon signature?
The organic rating?
Yes.
No.
Do they look for that signature?
Oh,
to label it?
I know your question. This is what he's talking about. This is a good question. Do they check for is the thing organic in the organic rating? So if I was to produce a product to these people and go, all right, my organic rating for my prunes is this, do I have to prove that this is organic to start with? Well, I reckon the lab testing this, well, short answer, no. But the lab, because I can just go, I want my ORAC value rating of this, my fruit and veg, and it doesn't matter where it comes from, is it synthetic or not? But that's just the actual ORAC value rating. But the O stands for organic. Oxygen, see? So it's got nothing to do with organics. So it's only a rating to say how much antioxidants or free, how much free radicals it can kill. Oxygen radical absorption capacity. So how much free radicals the molecules can absorb. In other words, how much antioxidants does it have in it? So it's nothing to do with organics, this rating. But growing organically, you should get a higher number of this number. Does that help? It's pretty. I know I'm going around and stuff.
Now you kind of lost me right there. But
yeah, see,
I gotta stay tuned next time around so I can glean some more of this knowledge from you. I learned a lot just being here today.
That was spot on. That was absolutely spot on.
That
that hit the nail on the coffin. But who is to say when you absorb the harvest or the fruits of your labor from organic or inorganic synthetic, that I did not provide everything that you know is automatically provided in a organic grow? How is it you can say to me that my inorganic grow is not sufficient? Because at the end of the day, if I provided everything that you feel, we touched on this in the last live, and I want you to kind of bring it up. If I provided every element, every nutrient, everything that's supposed to be there, and it was absorbed microbially and applied to the plants, what is that one thing that cannot be done inorganically? And you was talking about the electrons, sir, in the soil. Last Saturday, you was talking about the electrons and certain particular nutrients that cannot be absorbed because of that.
Oh, like an antagonistic effect, like
Yes.
a blocking effect. It's called Mulder's antagonistic wheel. Mulder's antagonistic wheel. Yes, I'd just like to see it, please. This one. Full on.
I mean, this is my ply to know that I'm not being biased. I want information on both sides.
And Loki, just to know that if you weren't confused, I'm sorry, mate.
Oh no, that means I need to keep watching. I need to keep watching so that I won't be confused next time around. I'll learn more.
No, this is hard even for me to explain. So am I sharing it, mate? So he wants to know about the molecule, the different nutrients that have effects on each other. So it's called I'll put this in the description below. It's called Mulder's antagonistic wheel. And wow, look at this one. I'll go this one. That one looks really good though, eh? All right, I'll put this one in. And it's not spelled with a U, it's spelled with an O. It's not M, it's Mulder. Oh, it's an S. Sorry, I was wrong. It's spelled with a U, like mold. But this is it here. So if I've got calcium, what will it work with? If I've got magnesium, what will it work with? So if I go and if I put it with phosphorus, will it work? Okay, here's stimulation. It's got the black one. Stimulation, a high level of nutrient increase the demand by the plant for another nutrient. So in other words, they work really well with each other. The other one is opposite antagonism, decreased availability of a nutrient to a plant due to the action of the other nutrient. So if I again put magnesium in, and if I go and add potassium, well, we've got this antagonistic line going both ways. So in other words, it's not going to work well with.
Oh, you spinning there for a second. Yeah, and it's sort of like when you put too much cow mag in, and then you put in too much magnesium. They have to be in a certain proportion, otherwise they don't work well together, or it'll throw one of them off so what doesn't absorb properly.
Man, I don't know what happened, but hey, CC done got the fuck on. He going to your screen too?
Yeah, it dropped.
Yeah, they the cancer boy.
We're still in StreamYard though.
Oh no, we live on his channel.
Yeah. Check the other one. Yeah, even
Come
on
back, CC. How do you feel about There you
That's
go.
really, really odd.
I got a glitch in your bandwidth.
That's a shame because I went to a real good summary at that. I don't know where I got up to. Where did I get up to?
Antagonistic.
You got up to nothing. We heard none of it.
Okay. Oh, at least I can start again then.
Yep. Start from the top.
Yeah, you're talking about how the potassium and magnesium or something like it doesn't work well together, or phosphorus. I'm sorry.
Well, this is the Mulder's antagonistic chart. I'll put in the description below to get to this page. So if I was it works on the nutrients to work within each other, and it's precision agriculture. So this is why you'd want to do this. If you want to add elemental form of synthetically, this is a tool that you will use. So magnesium as an example. Let's add some phosphorus. Sweet, black line. Stimulation. High level of a nutrient increases the demand by the plant for another nutrient. In other words, they work well with each other. All right, let's add some potassium with magnesium. Double arrow both ways. Means antagonism, decreased availability of the nutrient to a plant due to the action of the other nutrient. So you can see there's not many black lines that work well with each other. That's why they also bottle different nutrients in separate bottles. So they don't precipitate, it's called, and they also don't do other chemical reactions. Over. So that's full on. That's Mulder's antagonistic wheel.
It definitely looks straightforward.
No, it's not the murder wheel. Sorry. Internet, yes, sorry. Yeah, I'll be back. I was halfway through the spiel then, and I looked down. I thought, no one's saying anything. I thought, oh gosh, I can't even see the screen. Oh no. Yes. Time to walk the dog. Yes, it is time to. You're going for an hour 45. Thanks for everyone who's watching. Press that button if you think it's good. We can do this again. Yield source and local. It was pretty fun. I enjoy your questions. I enjoy your mannerisms. You're polite and you're respectful. We went back and forward, had good banter.
Appreciate you having us. Yeah, thank you.
So I hope you both are welcome to do this. Again, and it actually made for a better show. I think everybody else would have enjoyed it too, because instead of me just going on, and my throat hurts, I don't get any breaks. I've got to choose what people want. You can ask questions. So I liked it.
Awesome. Well, what I'll do is I'll take some snips of this and we will share it as well. And I really do appreciate the breakdown of the science. I know that you're still a student, and I would love to keep dwelling and deeping into the mind of a student until instead of a mind of a professor, because students love to learn and professors love to teach, you know.
And one good thing in my situation, I can ask my professors these questions. So if I can't get a good enough answer, I'll put it up to the chat to them, and they'll give me a really good answer, and it's from them.
Awesome. Well, thank you for having us.
Thanks a lot. Appreciate it.
And we will come back next time.
Yeah, stay on for a sec. Thanks everybody for watching. I'll see you again next week. Appreciate everyone's ears, and happy breeding, happy growing, good health to you all. Thank you. Geez, hey, where do we find Loki? Where do we find Yield Source? Shout yous out.
Oh, I found them on a live, and I saw you that time that you guys were talking about the triploids and the diploids and all that other stuff. I remember you from that episode.
Cool. And how do we get to you, Yield Source?
You can find Yield Source by just typing in Yield Source. If you type in Yield Source in Google, you'll find me.
Woohoo! Support. Thanks, everyone. See you next week.
Peace.
Take care. Thank you.